All right, to, wrap up Module 5 here, let's talk about some aspects of climate change. So, as always, you should be following along within your textbook. So, remember to read your textbook. Hopefully, you're reading it multiple times, but the name of the chapter that we're covering here, Chapter 8, and we're also covering Chapter 11, but most of the focus is on Chapter 8. Uh, the name of this chapter is Climate and Climate Change. So, if we kind of skip down to that section on global climate change here, make sure that you're examining the content and the data provided within this section, but let's just look at a couple things here within the PowerPoint. So as we can see here, if we look at the global average temperature from 1850 to 2019, we've had pretty reliable records on temperature since the mid-19th century, since 1850. And obviously technology has improved especially in the past 30, 40 years. But, we have pretty reliable records that go back about 170 years ago now. However, scientists can also determine temperatures from before 1850 by looking at all sorts of data and just, empirics from other fields. So there are dozens and dozens of ways to estimate and to infer temperatures from previous times and previous epochs even. So this can include the examination of ice cores and our ice caps of the world, as actually drilling into ice will kind of tell you the story about temperature and like fluctuations in temperature through time. The examination of microorganisms like foraminifera that are found on the ocean floor, a field called dendrochronology, by which examining tree rings, simply examining the interior portions of a tree will tell you about temperature disturbances or heat disturbances, changes in the climate for a given year or given decade, for these older trees. But there are dozens and dozens of different fields related to climatology by which scientists can kind of reconstruct the climatology of previous eras. Nonetheless, if we were just to focus on recent data and reliable records of the past, let's say, century, since let's go back to 1920, if we were to do this trend line for global mean temperature here, you see not only an increase but a marked increase from the previous few decades within this particular graph here. So in the second half of the 1800s, you see a slightly increasing trend line. But since 1920, a dramatically increasing trend line. And so, the vast majority of scientists, not only domestically but internationally, agree that a lot of this is driven by anthropogenic means, meaning human-induced means, especially with the greater emittance of or use of fossil fuels. So the Industrial Revolution started in England, about 250 years ago. And so obviously there was kind of a lag there in the 1800s, just a kind of a slight increase in global temperatures, but we've had this significant increase in the past century. And if we were to examine this graph closely here, we've had an even greater increase in the past, we'll say 40 years, the last 4 decades, since around 1980. Now, not all places in the world are heating up to a significant level. Some are staying pretty close to the average. So often climatologists will not only pick a specific moment, but usually like a 30-year period in time to compare temperatures to. So as you can see here in this map from Berkeley, we have relative to the 1951 to 1980 average. So we're looking at temperature anomalies or departures from the norm here. As you can see, most of the map is in that kind of shade of yellow to beige, meaning just slight increases, but we do have many areas of red to dark red. And as you can see geographically here, it tends to be the greatest in the Arctic or subarctic areas of the world, our high latitude areas of the northern hemisphere. So we're looking at Siberia, Greenland, by which we've had the greatest temperature increases. Now, overall, if we were just to look at the global mean of temperature increase in the past century or so, by most measures, it's about 0.6 to 0.8 degrees Celsius, as you can see here, which comes out to about 1.5 to 1.8 degree increase Fahrenheit, which doesn't sound like a lot, but if you have that much of an increase, a degree and a half, 1.8 degree increase in Fahrenheit, that is going to have a significant impact on all sorts of things, all sorts of ecosystems, most certainly on the ice caps, leading to greater melting and thus an increase in sea levels. Now, this increase in sea levels might seem minuscule because this increase in sea level tends to be, a fraction of an inch, but even that amount can have a devastating impact on many coastal areas of the world or insular areas of the world, like island countries. Nonetheless, more areas of the world are heating. Some areas are remaining the same, and some areas are even cooling, as you can see with these blue patches. But more areas than not are warming and warming significantly. Now, to determine to what level is the anthropogenic effect, meaning the man-made effect, it's difficult to do so. Are humans responsible for 20% of this warming, 80% of this warming? It's difficult to determine. Some scientists will have more moderate figures, others will have much higher figures. There's a wide range of kind of estimations and regression models as to what the anthropogenic effect is, but from dozens and dozens of different fields of study that are related or semi-related to climate change, there tends to be the vast majority of those scientists that agree that humans are at least partially responsible, if not significantly responsible. Now, with that being said, with our increase in temperatures, does that lead to more erratic weather or more severe weather? Well, as of right now, the data does not suggest that. It does not. Now, that does not mean that the future will not be characterized by more erratic weather, but at least when we look at data over the past, let's say, half century, there's not a clear indication that we have more erratic weather or more severe weather by most measures. Okay, so for example, if we look at this particular graph here, global tropical cyclone landfalls of hurricane strength. If we were to look at, just a trend line over time, so this starts with 1970, ends as of 2019, we see that for both, the gray bars indicate category 3+ in the Saffir-Simpson scale of hurricanes. So remember, hurricanes, typhoons, and cyclones are all the same. 3+ would be your strong cyclones. The gray bar, if we were to do a trend line for the gray bar, it would be pretty much straight across. Some years higher than others, as we see in certain times here, but some times are lower than others as well. If we were to have a trend line on this particular histogram, it would be pretty much straight across over this 50-year span, simply meaning that we don't necessarily have a long-term trend of either more or fewer strong cyclones. And if we were just to look at cyclones in general, the black bars, categories 1 and 2, same thing. In fact, if we were to draw a trend line, it would be slightly moving downward. How about tornadoes? This is all tornadoes, EF1 and plus. So we see EF1 tornadoes being the majority of tornadoes here in blue, but our strong tornadoes in 3, 4, and 5, yellow, green, and orange. If we were to draw a trend line from 1954, so this is going back almost 70 years to 2020, the trend line would be pretty much straight across. We don't see this upward trend here in the past 40 years like what we saw with temperature. But here's an important thing to remember. With tornadoes, you have to have that clashing of cold air with warm air. And so if temperatures are increasing globally, and especially increasing in our upper latitude regions of the northern hemisphere, what that means is that you're going to have less intense clashing between air coming from the north and air coming from the south. So if that air from the north is not as cold as it normally would be, then that convergence would southerly air, or air coming from the south, is not going to be as intense and thus is not going to create as turbulent conditions in the atmosphere. So that's a very important thing to keep in mind. So with increasing temperatures in our upper latitude areas, our northern locations, perhaps that would lead to even fewer tornadoes or fewer intense tornadoes. That's conjecture, but just based off that simple principle, it makes sense. So that's why the trend line over time here since the 1950s has been slightly moving downward for tornadoes. And so similar graphic here, annual count of violent tornadoes, EF4 and EF5, so enhanced Fujita scale. As you can see, even though there's no trend line here on this particular graph, if we were to provide a trend line, just the long-term average conditions and expected conditions, slightly moving downward. How about droughts? Well, I'll come back to that slide, but I just took some students to many national parks out west. We also stopped at Lake Mead and Hoover Dam. And so as you can see here with Lake Mead, which is formed by the Colorado River, if you were just to look at water levels are over 100 feet below what they once were, as you can clearly see right here. The Colorado River no longer makes it to the Sea of Cortez, which is part of the Pacific Ocean. It just runs dry there in Mexico. Colorado River in many parts is, 8 inches deep, 12 inches deep. It's extremely dry out there. There's been prolonged periods of drought out west, and those droughts continue in many parts of the out west, of the western U.S., excuse me. So, it's easy to chalk it up to drought around the world, but if you were to look at drought around the world, it's actually somewhat trending downward. So that's what we see here. Global area and severe meteorological drought, 1901 to 2017, measured by Standard Precipitation Index. So even though there are many areas in the western U.S., like out in California, Utah, that are experiencing prolonged drought, very serious issues with drought, as it relates to wildfires and just issues with irrigation and all that. Globally speaking, drought is somewhat down. And so we see that in this journal article from Nature, from the journal called Nature, one of the most prestigious and widely read journals of the world. It's not there. That there's little change in global drought over the past 60 years, coming from Nature here. And so as scientists, when we're observing things, and we're using empirical data, what can be observed, it's important that we kind of take a step back and look at the greater picture of things. We have a more comprehensive examination of the data rather than just looking what applies to what immediately surrounds us. Going back to the PowerPoint here, if we look at this particular graph, very interesting. Global deaths from climate and non-climate catastrophes, 1920 to 2018. So in essence, we're looking at the past century. Now, in the past century, the global population has increased fourfold, meaning that the current population of nearly 8 billion people globally is 4 times greater than what it was 100 years ago, back in 1920, by which it was close to 2 billion people. So we have 4 times as many people on the planet, but as you can see here with this blue line, climate-related deaths, floods, droughts, storms, wildfire, extreme temps, and so forth, has not only decreased, but has decreased by over 99%, despite having 4 times as many people on the planet. So this does not mean that going forward, we will not face issues of climate-related catastrophes and high death totals and all that, but just looking at the data simply, over the past century, the number of people who have perished from such things has precipitously dropped off. And so it makes sense if you look at improving conditions around the world, especially in lesser developed countries, those found in Africa, Latin America, and Asia. As their economies improve and as socioeconomic conditions improve, they are better able to withstand natural disasters. And so as they move to more modern forms of energy production and consumption and all that, even if those forms of energy consumption may be leading to higher temperatures in the world, they are also better equipped to withstand, some of the problems posed by, increasing temperatures. So for example, if you take a country like the Philippines, and let's say a typhoon rolls by the Philippines, if people have sturdier